Okay, so we're going to finish 3-3 today. So I had you write this function down yesterday, so we'd be ready to go. It seems like it's long, but it actually doesn't take too long because finding the zeros, this is already in factored form, so the zeros are pretty easy to find. Okay, so if I were to find the zeros, I set each part that has an x equal to 0, so if 7x equals 0, x equals 0. Okay, for x minus 3, x equals 3. For x plus 5, x equals negative 5. Okay, for 2x minus 3, yeah, 3 over 2. Okay, good. We will talk about those, but for zeros, they don't play a part. And x plus 2 to 0 is negative 2. Okay, so that was part A. I want to go through then and name the multiplicity of each zero. So to do that, I'm going to make this chart. So here's where I list the 0. This is part A. Multiplicity. Part B. And then part C asks about what happens at those zeros. Okay, so I'm going to put my zeros, 1, 2, 3, 4, at least 5 zeros in this table. So 0, 3, negative 5, 3 halves, and negative 2. Okay, so the exponent outside of the 0 is the multiplicity. Okay, so for my first one, 7x, well, I don't see an exponent there, so that means that the exponent is just 1. The multiplicity is 1. Okay, for 3, what's the multiplicity? What's the exponent outside? 2. Okay, good. For negative 5, the multiplicity is 3. For 3 halves, the multiplicity is 1. And for negative 2, the multiplicity is 2. Okay, so let's talk about the actions. So we did these yesterday. So when it's odd, it goes through the graph. All right, and specifically when it's 1, it goes straight through. All other odd multiplicities have a little inflection. When it's even, so when the multiplicity is 2, then there's a bounce. So if the multiplicity is 3, does it go through or bounce? Through. And it has an inflection. Okay, when the multiplicity is 1, does it go through or bounce? Yep, straight through. And then 2, when the multiplicity is 2, does it go through or bounce? Bounce. Okay. So there was part A, B, and C. D says determine the y-intercept. So for y-intercept, you have to work this out a little bit because that's when you plug in 0 for x, So you have 7 times 0, and then 0 minus 3 squared, 0 plus 5 cubed, 2 times 0 minus 3, and then 0 plus 2 squared. Okay, so you plug those in. Because you were ending up multiplying here by 0, you can see maybe that it's just all going to be 0. But if you didn't have this x out front, you would have to be calculating these. You're not necessarily going to get 0. When it's in factored form, it's not just the c value. You have to actually plug it in. Okay, so it asks for the y-intercept, which is a point, so I need the ordered pair, 0, 0. Okay, part E asks for the end behavior. So what I need to do, because this is in factored form, so when it's in factored form, we don't know the degree just by looking at it. But if I add all the multiplicities, that will give me the degree. Okay, so if I add these, that will tell me the degree. And the degree is important because I want to know if it follows an odd degree or an even degree, the end behavior. So that's 3, 6, 7, 9. So this is degree 9. Okay, so the degree is odd, and the leading coefficient, so the number out front, so what is the number out front? 7. And what I care about that is whether it's positive or negative. So 7 is positive. Okay, so it's odd. So this follows the same in behavior as like a linear or a cubic. Because it's odd. So a cubic, looks like this. So down, up. All right, and positive means it stays the same. If this were negative, then it would be opposite, so it would be reflected. So my end behavior is down, up. Okay. If it were an even degree, then the tails go in the same direction. So it's like a quadratic. They go up, up, or if it's negative, they go down, down. Okay, so let's name part F is to sketch the graph. So I'm going to use all of this information to sketch. Okay, my end behavior is down, up. So I'm not necessarily going to connect to those arrows, but that's just going to help me know where to start and finish. Okay, so these are my zeros, these 5 over here. So these are my x-intercepts. So 0, 3, negative 5, 3 halves, and negative 2. My y-intercept is 0, 0, which I already have a point there, but you don't always necessarily have, it's not always going to be 0, 0. Okay, so I know I'm starting down here in this third quadrant, and the first 0 I'm going to get to is negative 5. So at negative 5, what do I do? Okay, I'm going to go through it. And because it's 3, I have a little inflection, something like that. All right, the next 0 I get to is -2. So what do I do at -2? There's a bounce. Okay. Then I get to 0, and at 0 I go straight through. And then what's the next 0 I get to? 3/2, and I go straight through. Okay. And then I finally get to 3, and at 3 I bounce. So I started down here in this third quadrant, but I know that I had to end up here in the first quadrant. It should work out with your actions that you end up where you're supposed to. Okay, so now I'll erase these. We haven't done the location of these local maximums or minimums. We've done them on the calculator, so it is possible to find those. But right now, that's not what we're looking at. We're looking at the zeros and the end behavior. Okay? Questions about that? Okay, so we're going to start finding zeros. Okay, well, what I want to do, the easiest way to find zeros is to factor. Normally, we just start factoring when we have a quadratic. And this is not a quadratic because it's x to the 4th. But it is of quadratic form. And we know it's of quadratic form because, first of all, the degree has to be even. And then the second exponent has to be half of the first. And then you have a constant. So x to the 4th, x squared constant is of quadratic form. So would x to the 6th, x cubed constant. That's of quadratic form. So the second exponent is half of the first, and then you have a constant. 8, 4 constant. That would be of quadratic form. So when it's in quadratic form, you can factor it like a quadratic. So 2 binomials. Just instead of x and x, you're going to have x squared and x squared because you have to multiply to be x to the 4th. All right, so factors then of -100 that add to give you +21. Okay, so 25 and 4, and which one's negative? The 4. Okay. These are not linear factors yet, though. They're not linear yet. I have to factor them more. So what will x squared plus 25 factor to? Okay, good. You have x minus 5i and x plus 5i. Because it's plus 25, these are imaginary. And what about x squared minus 4? Okay? And it's difference of squares, so these are real numbers. Okay. So this is the linear factors. And then it wants us to find the zeros. Does it say real zeros? No. So you want to find all of them. You're going to include the imaginaries. So negative 5i, positive 5i. Negative 2, positive 2. It's x to the fourth, so there are 4 total zeros. But how many x-intercepts are there? Just 2. Just your negative 2 and 2. I want to add just a little factoring note. Okay, so you can factor other things like difference of squares even if you don't have perfect squares. So let's say you have this. 7 is not a perfect square, but you can still factor it. You just get an irrational number. So, like up here, 2 is the square root of 4. So you have square root of 4, but that simplifies to be 2. 7, that square root doesn't simplify, so you just have plus square root of 7 minus square root of 7. Then if it's x squared plus 7, then it's square root of 7i, square root of 7i. You have to include the imaginary part. Usually, you're not going to have both. So this is called, like this one up here, this is irreducible over the real numbers, but I can still factor it. This is irreducible over the rational numbers, but I can still factor it just to help me get my zeros. Okay, so this trick might come in handy. Okay. Skip that and talk about this. So you might remember this from pre-calc or algebra 2, rational zeros. You do your p's over q's. So you get a nice list. Okay, so I want to just list the possible rational zeros. So P are the factors of the constant. Q are the factors of the leading coefficient. I'm not concerned with that this is a negative 2 because these are all going to be plus or minus. So my P's are plus or minus. And then what are the factors of 2? 1 and 2. Okay? My Q's are the factors of 9. So plus or minus 1 and 9. And what else? Yeah, 3 and 3, so 3. Okay, then the possible rational zeros are P over Q. So I'm doing P over Q. So I got to do 1 over 1, 1 over 3, 1 over 9. So 1 over 1 is 1, 1 over 3 1 over 9. So a lot of times you'll see it written like this, where you have plus or minus and then you have these braces. Okay? Then I have to do 2 over 1, 2 over 3, and 2 over 9. 2 over 1 is 2, 2 over 3, 2 over 9. These are the possible rational zeros. This is x cubed. So how many zeros are there? 3. So obviously not all of these are zeros. These are just the possibilities. They're also just the possible rational zeros. So you could still have other zeros that are imaginary or irrational. But this helps us get started. This would not factor like a quadratic because it's 3 and then 1 and then constant. Remember, this first exponent has to be even because in the second exponent it is half of it. So it could be 2 and then half of 2 is 1 constant. Or 4, 2 constant, but not 3, 1 constant. That is not a quadratic form. Okay, so this didn't ask us to find the zeros, just the possible rational ones. So let's do that again. And then here in just a minute, we'll do so actually, if it goes over here, maybe. Nope. Okay. So this one does want us to find all the zeros. Okay, so we will use the rational zeros theorem. So we'll list out the possibilities, and then we actually need to find them. Find the ones that work. Okay, so 48 is my P, and 1 is my Q. So my P's. So I like to just start, like, go in order. So 1 and 48. There's several, so I'm leaving a big space. Okay, then after 1, does 2 go into 48? Yep, so 2 and 24. What about 3? Yes, 3 and 16. Okay, what about 4? 4 and 12. What about 5? Nope. What about 6? 6 and 8. And then the only one left would be 7. Does 7 go into 48? No. Okay. And then for Q, it's plus or minus 1. So then P over Q, it's just all of these factors of 48 over 1, which is just all the factors of 48. So these are the possible rational zeros. Okay. So if a number is a zero of the function, then what's true with regards to division? Yeah. Yeah, it can be divided by, yes, as a factor, and then, but that means what? So if it's a factor, it can be divided by, yeah, what's 0? Not necessarily the x-intercept. So those of you that kind of remember doing this, what's my next step? Now that I have these, how do I check? These are the possibilities, so how do I check to see which ones they are? Yeah, plug them into what? Okay, you can plug them in for x, and what should you get if you do that? Yeah, so you can plug them in for x, but there's another way, and I need it, that will work for this one, but I need to do it a different way because I'm going to have to get a smaller function. Anyone remember what to do next? Okay, well, I'm going to use division. I'm going to use synthetic division. How do I know if it works? Yeah, you get a remainder of 0, and that tells me that that's a factor and that it could be divided. So I know some of you knew that. I just wasn't hearing you say that exactly that. So I need to use synthetic division. And if I get a remainder of 0, that's when I know it's a 0. Okay. So these are positive and negative for all of these. So just start with 1 and negative 1. Okay, so my function is 1x cubed, 0, x squared, negative 28, and negative 48. Okay, so bring down your 1. 1 times 1 is 1. 1. Do I get a remainder of 0? No. Okay. So 1 didn't work. Let's try negative 1.
So you have to go through that every single one?
No. You do it till you find one. Okay. And most of the time, it's one of the first few. Okay. And we do it until we get a 0 and then a quadratic. Because once you get a quadratic, you can factor or use quadratic formula. Okay, so 1, 0, negative 28, negative 48. Okay, that's negative 1, 1, negative 27, positive 27. Do I get 0? No. Okay, so 1 and negative 1 didn't work. Let's try 2. Close. I'm close, but that still is not working. So negative 2 should work. So negative 2 should work. Okay, 2. So remember, synthetic division, you're multiplying and then adding down. And I get positive 48 and 0. Okay, so 1, 0 is negative 2. How many total zeros should I have? X cubed, so I should have 3. This doesn't mean that they're all going to be from that list. Okay, they might not, some of them might be irrational, or some of them might be imaginary. And that's why just plugging all of them in and getting 0 isn't always going to work. That'll help you find one, or maybe a few, but not necessarily all of them. So what you have to do once you get a 0 and you get a quadratic, meaning you have 3 terms after that remainder, that's x squared minus 2x minus 24. Then you either factor, and if it factors, then it's from you could have found it from your list. If it doesn't factor, then you have to use quadratic formula, and that's where you can get your other solutions like the imaginary or the irrational. This one does factor. Okay. So if I multiply to be negative 24, add to be negative 2, positive 4, negative 6. Okay, So these other two zeros are -4 and +6. So let's say you had tried 6 before you tried -2. That's okay. Whatever quadratic you got here would factor, and you would get -2 there. Okay. So this said, write it in factored form. So I got to write them as factors. So if my 0 is -2, that's x plus 2. My 0 is -4, that's x plus 4. And x minus 6. And then the zeros are -2, -4, -6. Okay? So we're going to do another one, and this time when we find a 0, we don't have a quadratic yet, so you have to do synthetic division until you get 3 terms. After your 0 remainder, 3 terms. You need a quadratic. So I'm going to skip this one here, and we'll look at this. So this says you can use rational zeros theorem or just skip that part and start by testing 1 and -1, because a lot of times 1 and -1, 1 or -1 are going to be one of your zeros. So they say, like, instead of writing out all the P's and Q's, just test for those two first, because they're always going to be part of your P's and Q's. And then if that doesn't work, then you can list this out. But I think we need practice listing these out. So factors of 24. Okay. And then factors of 3 are 1 and 3. So go ahead and list out the P's over Q's. Reduce. And if you get, more than one of the same number, you only need to write that number once. So it's all the P's over all the Q's. So first of all the factors of P are just over 1, so that's the whole P list. And then I need all the factors of P over 3. So 1/3, 2/3, 3 over 3 is 1, so I already have that. 4/3, 6 over 3 is 2, I already have that. 8/3, 12 over 3 is 4, I already have that. And 24 over 3 is 8, I already have that. Okay. So let's start by testing 1. So 3x to the 4th, 4x cubed, -21x squared, -10x, 24. Take a second to do this. It's worse? Yeah. Okay, so 1 is a 0. But this is not a quadratic yet. So this is the new polynomial I'm going to use. I'm going to do synthetic division again. But this time I'm using these 4 numbers. So then I can get down to 3. So I'm going to use this again. Okay. I also have to check 1 again. So because it works once doesn't mean that you're done, because you can have multiplicity. 1 could work again. So check 1 again. Okay, so it doesn't work again, but it did work once. I'm still going to use this new polynomial, and then I need to try some others. I think 2, I'm pretty sure 2 works, so let's go ahead and just skip to 2, just to save us some time. So I still use the same list. Yeah. Okay, so 2 works. Now I have a quadratic. So I can stop doing synthetic division once I get down to my 3 terms, my quadratic. So 3x squared plus 13x plus 12. And that is what I factor. It does factor. If it didn't factor, you would still need to finish by using quadratic formula. Alright, so it's going to be 3 and 4, because then my outer is 9x, the inner is 4x. So negative 4/3 and negative 3. So my answers, and this one says, as the problem, find the zeros. It doesn't say I have to write it in factored form, it just says find the zeros. It's x to the 4th, so I should have 4 zeros. So x equals 1, 2, negative 4/3, and negative 3. Any questions about that? Okay. All right, so we're stopping there.